Hello YouTube. Today we will hook in C#. I'm alright. I am back. I have missed you guys, so today I decided to bring a treat. In this tutorial, you will learn how to set a hook in memory that redirect the game's memory flow anywhere you want, all in C#. The example in this video redirects the cost function when buying towers in Plants vs Zombies, and instead adds it to the player, effectively making the user richer for every purchase. Wow! This detour, according to GPT, is called trampoline hooking, and this video will simplify the steps for your sake. The source code should be available in the Patreon if you want to download it. Please write in the comments of any suggestions you guys have, like the video. Also join the Discord, you might be able to voice chat with me there. Hello? Now, don't be a douche, do not use cheats for unfair advantages, do not use it in multiplayer, you will get banned, just don't do it. Now enjoy this tutorial. Welcome to today's showcase. So, in this video, you will learn how to take the cheat engine code injection template, uses jump hook, trampoline, hook, whatever it's called, whatever word you want to use, and instead code it in C#. So, here is all the code. Let's minimize some of it, create program that hooks the points function. So whenever we buy a tower, we would lose points. It will hook that and bring us to another location in memory, which allows us to gain points when buying tower instead of losing them. So right now we have 50 points. When I buy this tower, I should lose 50, but instead I gain 50. So this is an entry level example, and I hope you guys enjoy it. Welcome to the desktop. So you will be needing a game of your choice. Mine is Plants vs Zombies, since it is the best game of all time. And then you need Cheat Engine. I have a tutorial on installing Cheat Engine without all the bloatware and so on. Please check it out if you haven't. And let's get started. So, the function we will hook is the decreasing points when you buy towers in the game. So, you have your sun value points. You can buy a sunflower. It loses points. You can gain some as well. But we will find the address for the sun value, find the instruction that subtracts the points. We will reverse it with our hook. So, let's get right into it. We will search for our sun value, or whatever value you have. Change it up, just like in any other Cheat Engine tutorial. And there we have the value, or the address. Confirm that it's the correct. 555. Perfect. When we have the address, we can right click, then find out where it writes to this address to find the instructions. We will buy a new tower and check out what happened. So this instruction at this address, move ESI into EDI plus 5578 in hex, and the brackets tells us that this is a pointer. So if we click the disassembler and see some more code. Just before this instruction of moving stuff, we can see that it subtracts EBX and stores it into ESI. What we can do is we can rewrite this into add. So instead of subtract, we add. And now when we buy something, for example the walnut, we gain some points instead. We don't lose. So let's move it back a bit. Right, subtract again. And we will use a hook instead. So we will hook this address, trampoline hook, detour, whatever jargon you want to use, or whatever wording you might want to use, by opening the tools, clicking on auto assemble. In the auto assemble, we will write brackets enable, and then brackets disable. Once we hit Ctrl I, this code inject template will come up. We see that our address 1F634 was the subtraction, and that's fine. We will hit OK, and now we have a template. For this template, it allocates new memory. It generates some labels, variables for the hook address, the new mem address, and so on. So under the original code, we can see the code that we had before in the disassembler. Subtract, move, and we can change it. So if we wanted the same results like before, adding instead of subtracting, we can write add, click on file, assign to current sheet table, and we're done. So this is our sheet table now, or our sheet table, but our script. Invert sun subtraction. I don't know. That was the worst name ever. But once we hit it, we achieve the same result. So 880, 930. So adds instead of subtract. We can also see it in memory if we activate it, take out the memory viewer again, and now look at the address 34. If you remember, we have a jump now. So this is the hook, the detour, the trampoline jump, whatever. It creates a jump to our allocated memory, just like in the script. And if we right click, follow, we can see that we have our new code here. So it's there where it says add EBX into ESI, and then we move or paste the values in our sun address. Then we jump back. So here we see that it's 1F63C. If we follow that, we can see that it jumps just below. So how do we do this in C#? We will get right into that right now. We will start by creating a new C# project with the version .NET 8. Then we set the project build type to the same as the game. Plants vs. Zombies is 32-bit, so I choose x86. After that, we will make our way to the NuGet package manager and install the Swed library. You can install Swed32 for 32-bit games or Swed64 for 64-bit games. So we will write using then the NuGet package. After that, we create a new instance of Swed with the game name. You can find the game name in SheetEngine. We will get the game module base with swed.getModuleBase. You can see our address here. It comes from the .exe, so that's what I'll use. We will now get the process handle, but we will need some imports for that. So we will head down in the description and find this paste bin. We will copy all of the imports and paste them below our code. So we will get the process handle by using open process with the process VM operation. Now we might not need the process VM write, but I wrote it anyways because who cares. Let's create the hooking method. So we will create a new function or void, make detour. It's the same as hook or trampoline jump, with the address of the hook, the destination, so where we end up, and then the bytes to patch. So it's not always a perfect 5 bytes that you can just rewrite, so we will use some knobs. So the first thing we will do is calculate the relative offset. We will take the destination, subtract the address plus 5, because a jump will take 1 byte for the jump instruction, then 4 bytes for the address, and also create a byte array for our bytes to patch. We will fill the array with knobs, so do nothing until we have our hook and let the user decide how many bytes we should patch. So if you watch the memory viewer again, we would take the amount of bytes. In our example, we had a subtraction and then the move instruction from the assembly script, and just follow it if you don't know how much to know. We will knob these instructions and then just add our jump. So if we check our jump here, you can see that it says jump and the memory, and continue. We will set the first byte, just like in CreateHook, to the jump instruction, which is E9. I wrote 59 here because I'm a bit slow, but we will fix it later in the error fix, so don't you worry about it. After we have set the initial jump instruction, we will use the bit converter, get the bytes of the relative offset, then set it to the patch bytes with the opposite one, so we surpass the initial jump instruction. And finally, we write the bytes using the Swedz library. Next up is the CreateCodeCave function. This will return as a pointer. We will put in our process handle and the cave size we want. This function will be much shorter than the one we did 2 years ago. We didn't need all that stuff. In the function, we will call the virtual allocation with our process handle and int pointer null, because we don't want to set an address, then the cave size, the allocation type, and then the FL protect. Next up will be the FreeCave function. It will be a boolean, and we will take the process handle and then the cave address. In the function, we will return the virtual free allocation with our process handle, cave address, the DB size to 0, with the memory release. Now that we have the functions ready, we can go back to after our process handle and create a new int pointer, cave address. Then call our function CreateCodeCave, use our process handle, then 100 bytes for the size. It should be enough. Let's create a short console write line to show us where the cave is located at. Now let's define our detour address. We will use the int pointer.add and then use the game module and our address. Let's take a closer look in CreateHook. Or offset right here. So let's bring it back. This is the original code, and we will take this address right here. So you can right click, copy to clipboard, addresses only, and then simply make a comment right here. We take this, paste it right here, and let's continue. Let's write some new bytes into our CodeCave. So we will use swed.writeBytes, our cave address, and then the new bytes. So the code we will rewrite in our newly allocated memory is the addition instead of the subtraction. Let's simply activate our CreateHook script, go towards the jump, follow, and here just copy these bytes, right click, copy to clipboard, bytes only, and then just paste them into the string. So this will write that other code, and we will perform the detour on our own, so you will understand how that works as well. We can now create a detour, add our detour address and our cave address, and rewrite 8 bytes. Remember, we go back, here we have the jump, and check it. We had the sub instruction, then the move, count the bytes, 1, 2, 3, 4, 5, 6, 7, 8 bytes, and that's how many we will rewrite. Let's also make a detour in the CodeCave. We will use int pointer.add with the cave address and then offset it by 8 bytes because we wrote 8 bytes. Then we have int pointer.add using the detour address and then 5 bytes. So we will jump below the jump function in the original bytes and patch 5 bytes. We need to write it after the rewritten bytes. So if we go into the cave, inspect it, we would move below this and create the jump here. We have our address that we want to move to, which is our original address, detour address, but 5 bytes down. So again, you can follow that one, and we would go 8 bytes down. So from here, 8 bytes to get beneath it and sort of return where we left. So that's our destination, and the 5 on the end is bytes to back for the amount. So a jump instruction would take 5 bytes. So write 5. All right, let's continue. Let's also write out where we injected the hook. Next up, we will use a console.readline to make sure that the user can, once start the program, set the hook, modify the memory, but also then go back. So when they hit enter, we're supposed to continue and rewrite the memory. We will do that by using Swedz.writeBytes again, check into sheet engine, copy the original bytes, and then just copy that in the new bytes string. So to get our original bytes, really easy. You just disable your sheet engine script and then copy these bytes. Right click, copy clipboard, bytes only, and then paste. These are our original bytes. We can now free the cave, close the handle, and we're done. But let's add a console write line to notify the user and also let them hit enter on the end. All right, so let's try it out and hope that it works. So let's open sheet engine to have it side by side and see if it works. Now in the sheet engine script, we see that that's a jump function and then an up here, something else. And when we run our program, so we can see that something went wrong. Oh. All right, so I noticed the error. I thought this was an E. I don't know how I managed to do that, but we replace it and then run it again. So here we have the game. That's the instructions. We hit run and it replaces it with a jump and 3 knobs. Amazing. So if we follow that jump, we can see that we have our allocated address, just like it says in the console, df000, inject the code at 41, so on. We saw that earlier. Here we have the add opcode instead of subtract. We still have the move function and also a jump back. If we follow that, it returns precisely after our jump. It's amazing. And if we try to use our payment stuff in game, we now gain points instead of losing them. It's amazing. So if we hit enter again, we can see that removed hook and freed memory. You would also see some movement in the memory viewer. I didn't have it fully displayed, but we can see that the subtraction is back, move is back, no hooks, no jumps, no whatever. We can also go towards the memory and you would see that it's not allocated anymore. Let's test it again. Run it back. And go towards the allocated memory. Here it is. And if we hit enter now, just for you guys to see, it gets removed. So it's freed. You can allocate it again, do whatever you want with it. So when it's freed, you can see that you now lose money again. So that's how you perform the most simple hooks in C# using Win API functions. I hope you guys enjoyed this tutorial. Make sure to write down the next video that I should make. Some of the comments ask for an automatic offset updater. That would be really interesting, so I might do one of those. But please write down the suggestions in the comments, and I'll see you guys later. Thank you.